Welcome to LNP Renewable System Integrator. Today we are going to see the difference between a solar PWM, that is pulse width modulation charge controllers, and the Mppt, maximum power point tracking charge controllers. So when you saw the picture, you can see the pretty clear difference how it works. See here, in the first picture we had given a PWM charge controller, in the second picture we had given the Mppt. So when you look into it, this is how normally we used to make connections with the help of the PWM as well as the solar charge controllers. Both we are using for the DC applications. Okay, so one part with the help of the solar panel we will try to charge our batteries, and the output can be a DC one if required. Okay, using the inverters you can convert the DC to AC. So what are the things that we are going to discuss today? So today we are going to discuss two important things. One is that what is the major difference, okay, between the solar PWM and the normal Mppt charge controller, and what are the advantages of Mppt over the PWM solar charge controllers. So first let us try to know what is PWM. PWM is nothing but the pulse width modulation. It is the method of reducing the average power delivered by an electrical signal by effectively chopping it into discrete parts. Means we are just cutting it. Okay, so what we are going to do in the pulse width modulation, it is like a switch, making a switch on and off. What will happen? Immediately the sharp pulse happen and immediately down pulse will happen. So in the fast state, if you do this one, a pulse formed, that is called the pulse width modulation. Okay, and this is the block diagram of the pulse width solar charge controller. So you will have a solar panel. So the solar panel output, okay, will go to the voltage sensor and the current sensor, and we have a PWM generator. From the generator it will go to the boost converter. From the boost converter we are getting connected to the terminals. From there we are connecting to our loads. This is a simple view of a PWM solar charge controller. It means that it has sensors, that is voltage sensor and the current sensor inside, and we have a PWM generator inside. Okay, and next to it we have a boost converter. Okay, so this is the actual view of how the inside the board, how the things will looks like in a PWM. It's we have a heat sink, we have a different capacitors. Okay, we have a different controllers. Okay, and see how pulse width modulation happens. See, if you draw a waveform between a voltage and the time, okay, if you are trying to change the duty cycles, how the waveform will be. Let's try to see here. See here. See here, the width of the pulses keep on changing when we switch on and off frequently. So first thing that you be clear is that in the pulse width modulation, okay, we are just switching on and off in order to avoid the maximum pulse. That's it. We are just doing the modulation only. So if you are giving a 12 volt 7.8 amps power to a PWM solar charge controller, the output will be 7.8 amps 12 volt. It means there is no modulation or change in the power. We are just modulating the pulses. That's it. That is the only thing which is happening in the pulse width modulation. And in the market there are so many brands, so many companies are there in the business of pulse width PWM charge controllers. So these are the pictures of the real-time PWM charge controllers in the market. There are so many brands are available. So based on the cost effectiveness and based on the consumed load in amps, you can choose your PWM charge controllers. Next is the Mppt charge controller. So from the picture itself it is pretty clear. So in the other one only switch was there from the solar panel to the battery and to the load. That's it. But in case of Mppt, okay, we have a electronic circuits inside. We have a capacitors inside, we have a diode, we have an inductor, and we have a DC to DC. So as a whole we used to call the entire circuit as a DC to DC converter. Okay, so what is Mppt? Mppt is nothing but the maximum power point tracking, or simply we can say in the short form power point tracking technique. So in this technique what we are going to do, very simple, the variable power source. Okay, what we are doing with the help of a variable power source, maximum extraction of energy we are trying to do by continuously varying it. This is the simple technique we are going to do it. Okay, maximum power, okay, we are going to extract, okay, extract from the available one. How it is happening? So as we all know it, we have a capacitor, we have a diode. It means that the exact precise output. If you are using a xenon diode, maybe the precise output we can take. And if you are having a capacitors inside it, we all know it, capacitor act as a capacitor banks. So it stores the minimum voltage required for the starting up operations. Okay. So this is the block diagram of Mppt solar charge controller. So we have very more devices available inside the Mppt when compared to the PWM. In the PWM we saw only the voltage sensor and the current sensor. That's it. Okay. But when you see inside this Mppt, okay, we have a microcontroller, we have a voltage sensor, we have a current sensor, and we have a buck boost converter. Okay. And for the enhancement, okay, even for the battery also we have a voltage sensor. There only for a solar panel we have a voltage sensor. Okay, but in case of Mpt's, which are solar charge controller, we have a voltage sensor for batteries also. Okay, for the efficient operation, and for the external device charging unit we are taking from the battery. Okay, and apart from it we have a Wi-Fi module, IoT nodes. Okay, and even for the requirement of for clarity we have a LCD displays also in the Mpt's. So it means when you compare the cost wise, the PWM and Mppt is little costlier because it has so many new enhanced devices inside it, and this is how it looks like inside Mppt. Okay, we used to have so many electronic devices like a MOSFET, we will have a heat sink, we have a buck boost converter. Okay, we have a current sensor, this is how it looks like. Okay, and we have a MOSFET drivers, we have a microcontrollers, as we told earlier, we have a LCD display. Okay, and see here we have an interface for IoT, we have LED indicators, so we have external charging units, we have USB ports, and most importantly the protection circuit of 25 amps, and we have a battery connectors like this. These are the most important things which often used to present inside a Mppt charge controllers. So if you draw a waveform, okay, with reference to voltage and the current, okay, your power is going to be in output. So see here how it is the pulse, how the maximum power point tracking is happening. See this video. So the session is going to be very much useful one. You can see here the maximum power try to achieve and give as an output. See here, let me tell you with an example. If you go for a Mppt charge controller, okay, if you are going to connect with a battery, okay, you are going to charge your battery with the help of the solar power available from the solar panel with the help of this Mppt solar charge controller. See here, we have an voltage of around 32 volt and we have a current of around 7.8 amps. But actually we don't need this much voltage, and also we need a little more current. So it is enhancing the current, so that eventually the required thing for the battery to charge is available. We have a proper 12 volt supply for the battery to get charged, but we had enhanced the maximum power point by increasing the current. So that is the Mppt solar charge controller is doing. If you are purchasing any sort of inverters with the Mppt feature, it means it has the maximum power point tracking, that is it enhancing the current. Current is very much important for the load to operate, because normally we often know that whenever you switch on a device, okay, normally it tries to consume more power, we all know it, but it try to consume more current. So if you provide less voltage or less current, eventually there is a possibility for issues to happen in those devices. So in order to overcome these things, so these Mppt solar controller are getting designed to provide an enhanced current. So how it looks like, so we all have a doubt. So in market there are so many brands, so many companies are available. So these are some of the real-time pictures of the Mppt charge controllers which is available in the market. Okay, with the main advantage is that with the help of these Mppt charge controller we can enhance the solar and the battery supply. Okay, we can and we can produce an output. That output we can connect with the inverters and we can run our AC equipments, or if you want to run only the DC equipments, with the help of these Mppt charge controllers we can run. Okay, we can get the required outputs. Okay, and most importantly for small Mppts there is no need for any separate power supply, because it is taking the supply from the solar panel and from the consistent power battery. Okay, but when you are going for a domestic purpose with a higher current rating, say for example, if you're going for a 30 amps Mppt solar charge controllers, 40 amps, 50 amps. Okay, when the current rate is getting increased, those controllers you can connect. You have a plug point to connect with a normal power supply, because it needs some power supply for the electronic components to work properly. Okay, and if you try to look into the pros and cons of these PWM and the Mppts, okay, only up to 60 amps we can use the PWM controllers, maximum size. But when you go for Mppts, up to 80 amps load we can use this Mppts. And most important things about the Mppts is that we can increase the efficiency up to more than 30%, especially in the cold climates. Okay, whereas in case of PWM, the efficiency is very low, as we all know it. Okay, and PWM controller has so many limitations. Okay, its system has a limitation, capacity limitations, but Mppt generally larger in physical size as well. And when you compare the cost, Mppt controllers are little costly, since it has so many enhanced electronic equipments inside it for the betterment of power. So as we told earlier, so when we use Mppt, we can increase the efficiency, okay, more than 30% when compared to the PWM normal solar charge controllers. So this is one of the example, okay, how the maximum power point tracking has happened when we draw a waveform between the voltage and the current. So this is the comparative view. So in the PWM, only the required voltage and the available current will we will get as an output, but we will have only the low power there. But when you go for Mppts, the current is getting enhanced and the required voltage to charge the battery is available. So we are increasing the maximum power. See here we have two examples. So we are connecting the Mppt with the 12 volt system, and we are connecting our Mppt with the 24 volt system. See here, in both we are using the 20 amps Mppt only, but what is the difference which is happening in the output? In the first, for the battery to charge properly, it is only giving the 12 volt battery output, okay, and it is enhancing the current to 20 amps. Whereas in case of 24 volt also, what is happening? We have two panels connected. So this 20 amps Mppt, what it is doing, it is providing the required output to charge those batteries, that is 24 volt, and also it is enhancing the current output to 20 amps. Thank you so much. Please subscribe and press the bell icon. So if you want to know more and learn more, you can contact us. We had provided the contact details here. So we are providing, okay, solar on-grid, off-grid, hybrid design, installation, testing, commissioning, consultancy, training supports also. Okay, and if you want to make your homes or your factories, your sheds with entirely with the DC lighting systems, okay, you can contact us. We will provide you the we will help you to establish the solar DC lighting systems inside your buildings, inside your required places, okay, where the EB power is not available. And if you need us to provide you support for this solar pump services where the EB power is not available, you can contact us. We have provided the contacts, and we are also providing training for the automation industry, that is building management system and building automation system, okay, building automation control system. We are providing trainings. If you had a plan to work in the GCC countries, if you want to work in automation industry to get a handful of salaries, then you can contact us. We are providing a training along with the certification. So we have provided the contact details here, and thank you so much.